Alright guys, so in this video I am going over Unit 2 review. So we already did 1 through 9. So we're going to start on number 10. Then I'm going to go back to number 1 and do number 1 through 9. But I wanted to make sure the beginning of this video is what we have not done in class. We have done these topics in class, but not these problems. So let's look at 10. So we're looking at 10. Our parent function. How we know what our parent function is our x is in the exponent, and our 1/3 is the base of our exponent. So that would be our parent function. If we were asked to write our parent function, we would have y equals 1/3 raised to the x power. But we don't. We're worried about our transformations. Our transformations is given for us to fill out. First, we're asked up or down. Our up or down. What axis is up and down? When we draw our graph paper or graphs, we have our y-axis going up and down, and our x-axis going left to right. So up and down is affecting the y's. So our y is on the outside. Remember me creating a y with my arms? Our -1 is on the outside of the exponent. So our -1 is telling us to go up or down. Well, when we're going up on the y-axis, we are going positive. Well, our -1 is not positive, so we want to go down to our negatives. So we're going to be going down, and that 1 tells us how much we're moving down. So then we have our left to right. Our left to right is our x-axis. So we're going to have our x affecting the x's going left to right. If we want positive versus negative, we've got to ask ourselves, what is inside with the x? What is inside the exponent with our x? +4. So +4 is telling us how to move left to right. So inside, we're scrunched up, we're mad at our parents, we're going to be disobedient to our sign. So if we weren't being disobedient, if we were just going to do what the sign tells us, it's positive. So we wanted positive on the x-axis, we would go to the right. But because we're scrunched up, we're being disobedient, we're going to go to the left. So we're going to be going to the left 4 units. So that is where I'm getting at my transformations from. Then I'm asked to graph it. So we're going to use Desmos. If you need to have a review of how to get to Desmos, you go to your Chrome. And if Desmos doesn't just pop up like it did for mine, if you go to Google, you type in Desmos, D-E-S-M-O-S, hit search. The very first one. For this one, it's not going to say the free Beautiful Math or Beautiful Math free, but it's still the very first one. You hit start graphing, and you will be able to use this tomorrow on the test. So we're going to put our equation that was given, which was y equals 3 times 1/3 raised to the x plus 1 minus 1. So in Desmos, I've got y equals, it was 3, parentheses, 1 divided by 3 to get our fraction, and then raised. So we're going to go on the outside of the parentheses. We're going to use our AB button so we can type something into the exponent. we have x plus 4. And we came across this during class. When we are in our exponent and we have multiple things in our exponent, we've got to use parentheses. So x plus 4 gives us that plus 4 in our exponent. Then we have subtract 1 on the outside. So this is what gives us our graph. We can zoom in by hitting the plus sign. Now if you hit the line or click it, there are gray dots that show up that gives you actual points. Or you can drag your point or your clicker to get exact points. You have exact point at -4, 2. So I'm going to go graph it. So I've got -4, 2. There's a point. Let me scroll down so I can actually see it. Then I've got exact point at -3, 0. So -3, 0. I'm going to drag my dot, see if I can get another exact point. So there's -2 at -0.667. Let's see if there's another one. Don't think so. So we're going to try to graph this point at our y-intercept. So we got 0. -0.9. So it would be somewhere right in here. Our graph would look like this. And there would our graph. There's our graph. Now, our domain. Our domain is our x. So as we are going all the way to the left side for our x values or horizontal axis, our x is going to keep going forever and ever and ever to the left. Very slowly, but always to the left. It also is going to go all the way to the right forever and ever and ever. So our domain is always going to be -infinity to +infinity. Now, for my range, kind of talked about it again today, but we'll talk about it again. Whatever my vertical shift was here, and whatever my vertical shift was here, is going to be where my range starts. So -1 is where my range starts, and it's also going to go up forever and ever and ever. So my biggest y value was positive infinity. My lowest y value is -1. How I know that is because if I keep on going and getting further out, my y's are going to keep going forever and ever and ever up. But they are not going to go forever and ever down. They are going to get really close to -1, but they're never really going to cross -1. Y is -1. So we're trying to get to that y equals -1, and we're never going to get to it. So that is why our range starts at -1, but it does not include it. Now, reading left to right, our graph is going down, so it is decreasing. our asymptote. Our asymptote is one of those ones that has to match everything of our vertical shift. Vertical shift is at -1, but do not just leave it at -1. It has to be y equals -1 because it creates a line at y equals -1, and that line is our asymptote, not just a value. So then we're asked in behavior. In behavior, as our x values, so as our x-axis goes to the left, what are my y's doing? My y values are going up. So if they're going up, they're going to reach positive infinity. Now for my last in behavior, it has x is going to -infinity. So that was opposite. Excuse me. So as our x values, we're going to -infinity, which is going to the left. We're going to positive infinity. If we have our x going to positive infinity, which is going to the right, we are slowly approaching y equals -1. So let's recap. What has to match when we're talking about these transformations? So let me change the color so you can see it. Our -1 was on the outside. So our -1 was also what told us our vertical shift. It also told us at the beginning of our range, also told us our asymptote. It also was our end behavior as x approached positive infinity. So let's move on. So then we get to 11 and 14, where we have to find the inverse of a function. So we're not solving, we are just finding the inverse. When we're taking the inverse, we first have to flip the x and y, and then get y by itself. So let's do that. We have, instead of y, we have x equals 9y. Now my next step is to get y by itself. So I'm going to switch the order. I'm not going to change the actual equation, but I'm going to switch the order so it looks like we're used to it. So we have the base of the exponent, so that's going to be the base of our log. And then we're taking the log of our x, and we're setting it equal to our exponent. So that would be our inverse equation. So let's do 12. 12, there's a little bit more involved. 12, we still have to flip it. Right now, there's no y. Why is that able to happen? Well, this h of x, is the same thing as f of x. And f of x we can change to y. So this whole thing can be changed to y equals 4 times 3 raised to the x plus 6. So now we don't have to look at the h of x. So I'm going to switch it. So I've got x instead of y equals 4 times 3 raised to the y instead of x, because we're taking the inverse, plus 6. So the base of our exponent is not by itself yet, so we can't do anything about the exponent yet. We have to get rid of this multiplication and this 4. So we're going to divide by 4, divide by 4. So we're left with x raised to the y plus 6 equals x divided by 4. Now we have our base of our exponent by itself, So now we can create our log. So now we have log base 3. Then we're going to take the log of whatever it's equal to, so x divided by 4, and set it equal to our exponent, which was y plus 6. Now is y by itself? Remember, that's the whole point of an inverse, is to get y by itself after flipping it. So let's get y by itself. There's a adding 6, so we're going to subtract 6. Subtract 6. 6's cancel out. You're left with log of 3. Taking the log of x divided by 4. Subtract 6 equals y. And that is your inverse equation for number 12. Then we go on to 13. So 13, we're given a log, and we got to find the inverse. So we have this f of x. We can change it to y. Then we're going to flip our x and our y. So we have x instead of y equals log base 7 of y minus 8. So if you need to highlight it, do whatever you need to. Y needs to get by itself. This negative 8 is attached to the log. Those parentheses prevent us from just adding 8 and getting rid of it and putting it on the other side. So we've got to deal with this log before we can deal with the 8. So we have log base 7 of y minus 8 equals x. We're putting it in order just so it looks like we're used to. We have the base of 7 for our log, so that's going to be the base of our exponent. We're going to have our x in our exponent, and we're going to set it equal to what we're taking the log of, which was my y minus 8. Now we can deal with the y. Now we can get that negative 8 away from it. So I'm just going to rewrite it for us. It was y minus 8. So we're going to add 8 to both sides. Negative 8 plus 8 cancels out. I'm left with x, or 7 raised to the x plus 8 equals y. And there is my inverse equation. Then I have 14. 14. I'm going to rewrite it again. So I have what I'm used to. When I'm rewriting it, I'm going to put my y in the same place as my x. Then I'm going to get y by itself. So I'm going to have my base. First of all, do we have our log by itself? No, we do not. We have this negative 9 attached to the log. So we have to get rid of it. So plus 9 plus 9. Negative 9 plus 9 cancels out. You're left with log base 2 of y equals x plus 9. Then we can do our base. So then we can do the base of our log is our base of our exponent. We're going to raise it to the x plus 9. And we're going to set it equal to y. Y is by itself now, so it is our inverse equation. So lastly, 15, 16, and 17, we're asked to determine if it's growth or decay and by what percent. So this one, we're going to have to refer back to something that some of you did not know today. Our general form y equals our a times 1 plus or minus our r for our rate raised to our x. where R is our percent. So we've got to ask ourselves each time, what is that R? So 15. 15, is this number 1.01 above 1 or less than 1? It's above 1. It's greater than just a 0.0 or 1.0. It's a little bit bigger. So it is growing. Again, because it was greater than 1, it is growing. So then we have to ask ourselves, in our general equation, we have 1 plus or minus, well, because we already said it was growth, it is adding. Our R, X, and if you really need that A there, you can. So to get 1.01 in the parentheses, what would we have to add to 1 to get that? Another way to look at it is if you have $1 and you want to have $1.01, how much cents do you have to add to that dollar? So here's your $1. Your R is how much cents you're adding to it. And you want to get to $1.01. You have to add 0.01. Well, 0.01 translated into a percent, you have to move it over 2 spots, is 1%. So your answer is simply 1%. So let's do it for 16. 16, we're given 0.67. Well, is 0.67 greater than 1 or less than 1? It is less than 1. It is less than because it's that decimal. If it is less than 1, it is decay. So then we have to ask ourselves, if we have 1 minus RR, how are we going to get 0.67? So another way to think about it, again, is subtraction because it's decay, is that we start with $1, we subtract some amount of cents to get to 67 cents. So we're going to ask ourselves, okay, so if we have $1 and we want to get to 67 cents, well, 67 to 70 is 3 cents, and 70 to $1 is 30 cents. So we've got to add 33 cents to $1, or take away 33 cents from $1 to get 67 cents. Well, this decimal of 0.33 translates to a percent of 33%. Then lastly, at 17, you have inside of your parentheses, you have 0.3. You're asking yourself if it is greater than 1 or less than 1. Well, it's less than 1. So if it's less than 1, it is decay. And you're asking yourself 1 minus R, and you're asking yourself how to get to 0.30. Again, same thing, if you can't visualize this, use the money thing. If you start with $1, you're subtracting at some kind of cents, and you want to get 30 cents. How much cents do you have to subtract? Well, you have to subtract 70 cents. Well, that 0.70 translated into a percent is 70%. So that is our percent for that question. All right, so for time's sake, I am going to do these into 2 different videos. So if you weren't here today, stay tuned.